Okay, so this warm-up is from last unit with our pattern of A. Okay, so we have our vertex at 3, -8, so we're down here. Okay, and then A is 1, which means you're following your typical input-output of input 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so we're up there. And then everything's on the same side because the negative squared are the same outputs. So our graph looks like that. Okay. Now, for the next one, you have a vertex at -2, 6. But then your A is -0.5. So instead of up, you're going down, and then you're going to have all of those distances. So over 1, down a half, over 1, down a half, over 2, down 2 instead of 4, over 2, down 2, over 3, down 4.5, over 4, 1, 2, 3, 4, down 8, over 5, in this case we can keep going, down 12.5, and then I think we run out of room. So then we just need to use our symmetric point, or you can count, it doesn't matter. And your parabola looks like this. So it's a little bit fatter. Sorry, my parabolas are really terrible today. Apparently that one's dancing. Okay. So that's what that one looks like. Then for the last one, we are at 0, -9, and our A value is 2. So now we're going to double. We're going up because it's positive. So we're going over 1, up 2, over 1, up 2, over 2 instead of up 4, we're going up 8. And then over 3 instead of up 9, we're going up 18. So your parabola gets a lot skinnier. Okay. So we're going to use that pattern of A throughout the week, and we're going to add some more functions on. We've just focused on quadratic. Now we're going to put on some new functions. So the first one we're going to talk about that we're going to focus on today is the square root function. Okay, we've done these algebraically, just haven't done them graphically. So we have a table here, at least to start building. If you look, if your input is -2, our output, hopefully you're thinking a negative under the radical, it's going to be imaginary. We cannot graph imaginary on a real number plane. Then, all right, so if our input is 0, the square root of 0 is 0. The square root of 1 is 1. So I'm focusing on this. Hopefully you picked up on that. The square root of 2, I'm going to skip because it's ugly. The square root of 3 is ugly. The square root of 4 is 2. And then notice I skip in my inputs down to 9 because the square root of 9 is 3. Everything between 4 and 9 as an input is going to get you a decimal output. That's not good to graph. We're going to stick with what are the nice, pretty numbers. Okay, so if we graph what we know, we're at 0, 0. We are at 1, 1. We are at 4, 2, and 9, 3. So your graph looks like this. Okay, so all I did was just evaluate all of my inputs and got my outputs. So by evaluating in this table, you can kind of see what this graph looks like. Now notice, I do not have anything on the left side of my graph, because as soon as I put a negative input in, I'm going to get an imaginary output. So let's talk about what that means about your domain. That means any x value that I want to put in has to be either 0 or positive. So my domain here is going to be from 0, and that's going to include 0, so it has a bracket, to infinity. I don't care what positive x value I put in there, but if I want to stay in the real number systems, my inputs have to be 0 or positive. So then let's talk about our outputs, because that's your range. So anytime I put a x value in, that obviously doesn't get me an imaginary. Anything in my domain that I put in as an input into this graph, I'm going to get an answer out. Well, look at where your answers are. You're never going to take the square root of something and get a negative number. So your range, as well as your domain, is only going to be positive numbers. Okay. Now, you think about your increasing and decreasing. You guys remember, We started talking about this last unit. This is going to be a huge focus in this unit, increasing and decreasing. You read the graph like a book, left to right. If you're going up, it's increasing. If you're going down, it's decreasing. So if I come from here where my graph starts, I am constantly, think about it like a roller coaster. You're going up, 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 up. There is literally no point I am ever going to come down again. Okay? The bigger inputs I have, the bigger outputs I have, which means my graph is increasing from 0 to infinity. Notice I'm including the 0. It's not a point of change, so we're going to include it. I am never decreasing here. Okay, so with quadratics, you always had half of your graph increasing, half of your graph decreasing, and your vertex was that point of change where you flipped from one to the other. When you're talking about square roots, because you can't take a square root of a negative number, and that obviously shifts your outputs, now you're going to have an either always increasing graph, or when we start talking about examples on the back, you'll either have always increasing or always decreasing. Okay, so if you think about your pattern, okay, we talked about our input-output pattern for quadratics. Input of 1 was 1 because 1 squared was 1, 2 squared was 4, 3 squared was 9, right? Here, if you go right 1 from your critical point, which I'll talk about in a minute, you're going to go up 1 because the square root of 1 equals 1, okay? If you go right 4, you're going to go up 2 because the square root of 4 is 2, okay? I don't care about an input of 2. I don't care about an input of 3. If I go right 9, I'm going to go up 3 because the square root of 9 is 3. Okay? If I go right 16, I'm going to go up 4 because the square root of 16 equals 4. Sorry, I don't need a comma there. So on and so forth, right? We could keep going. But basically, what you want to notice is that all of your inputs here, all of your x values, are perfect squares because you want to take the square root of a perfect square to get a nice pretty number. Okay? So what we're going to focus on today is graphing these without having to use a table. Obviously, you know we're not going to build a table every single time. So in order to do that, we're going to focus on our parent function and transformations. Okay, so a parent function just means a function where no transformations have occurred. So what we just graphed was the parent function of the square root of x. If you had just y equals x squared, that would be the parent function of a quadratic, okay? Now, the general form, this should look very familiar to you from vertex form of a quadratic, and it's going to work the exact same way, okay? You have K and H. So notice H and K. Think about this. H and K was your vertex. Well, if you're going to plot your vertex, H went left or right, K went up or down, right? It's plotting a point. So K is any vertical transformation I have. H is any horizontal transformation I have. However, remember from last unit, if you're coming out of the parentheses, you need to do the opposite. So if it's x minus 7, we're really looking at a positive 7, so on and so forth. Okay, and then obviously this value of A will either, I'm going to say stretch or shrink because it's either going to make it skinnier or make it fatter, so on and so forth. Except I can't spell shrink. Sorry. All right, so we're going to look at A, H, and K. So what that means, let's just start with the H and the K part first, and then we'll bring the A in on the back. If you look at these 4 examples, on here we put the square root of x parent function. So that's exactly what we just graphed above. But now we're going to move it. So if you look, this is f of x equals the square root of x plus 2. Okay, do you see how, of course I just circled that, now I want to go on. Do you see how that plus 2 is outside of the radical? That's like being outside of the parentheses in vertex form, so that's a k value. So if this is a k value, that means we're going to go up 2. So I'm going to take every single point and I'm going to move it up 2 from where it was originally. And my new graph looks like that. If I had the square root of x minus 2, it's still outside the radical, but now we're going to go down 2. So all of these points move down 2. And your graph now looks like that. Give it a little curve. It's not a straight line. Okay. Now, the difference between the first two and the last two. Notice the first two are outside the square root. That's like being outside the parentheses. These are inside the square root, so that's like being inside the parentheses. So this is the square root of x plus 2, so it's got to be a horizontal movement, but, I'm sorry, x minus 2. You're going to do the opposite. So instead of, you look at that and say, oh, x minus 2, I want to go left 2. But because it's horizontal, because it's coming out of the parentheses, quote unquote, here it's out of the radical, we are going to go to the right 2. So you do the opposite, and it's only for the value that's inside the radical. So I'm going to go right 2, right 2, right 2, and then my graph looks like this. And then obviously vice versa, on this one it says plus 2, so I'm going to do the opposite, and I'm going to go left 2. So I'm here, I'm here, I'm here, and that's your graph. Okay. All right, flip it over to the back. Now we are going to look at them, and we're going to talk about everything, domain, range, anything that comes up, okay? So if you take a look at number 1, you have this minus 5, okay? So it's going to ask you a slew of questions. Your homework is going to be just like it. Is it shifted left or right? Well, in this case, no, because you have nothing underneath the radical. You see how in number 2 you have that minus 3 under the radical? That's a horizontal movement, so no. Is it shifted up or down? Well, yes, that 5 is on the outside, so we are going to go down 5. Now, critical point. Let's go back to the front real quick. If you look, all of these graphs started right here at 0, 0, and then we might have moved it. So your critical point where everything is based off of is 0, 0. That's like your vertex of a quadratic. Everything was based off of your vertex in a quadratic. So here, my critical point was at 0, 0, but I'm moving it down 5, which means my critical point is now at 0, negative 5. It has not been reflected because we don't have a negative a value. It has not been stretched. Okay. So I'm normally at 0, 0. I'm going to go down 5 and start there. Now you're going to want to think, okay, what's my parent function? Because we're going to build a lot more on here. I have the square root of x. So inputs and outputs. The square root of 1 is 1. The square root of 2 is ugly. Skip it. The square root of 3 is ugly. Skip it. The square root of 4 is 2. The next pretty one is 9. The square root of 9 is 3. And there is your graph. Okay? So, let's talk about domain. X values, left to right. There is nothing happening on the left side of the graph. So your domain starts at 0 and goes to infinity. Now your range is different. If you look, your smallest y value here is going to be negative 5 because we shifted this down, and then it's only going to go up. So your range is going to go from negative 5 to infinity. Now I talked about this on the front. These graphs are either going to be increasing or decreasing. So in this case, when you start from your critical point and move to the right, you're going up, up, up. So you are increasing from 0 to infinity. Remember, you're always going to focus on x values, so it's going to match your domain here. You are never going to be decreasing because it'll never come back down. Okay. All right, let's look at number 2. For number 2, are we shifting left or right? Yes. Okay, that x minus 3 tells me that I'm going to do the opposite, so I'm going to go right 3. Okay, then the minus 2 tells me I'm going to go down 2. So it's like your h and k from before. That's what causes your critical point. Let's see, our critical point, we are going from 0, 0, we're going right 3 and down 2. So that means a positive 3 and a negative 2. So my critical point is now here. Okay. Now, reflected or stretched. There is no number, I mean there is, but we don't have a written number there, so we know A is 1, which means we will not reflect and we will not stretch. So we can follow our typical pattern. The square root of 1 is 1. The square root of 4 is 2, and then the rest of it doesn't fit on the graph, so same rules apply. Do as many points fit on the graph. Make it look nice. Don't make it look crazy. You don't want to go like way up or whatever. Okay? So now let's talk about domain and range. So we've shifted this a little bit. My smallest y value, I'm sorry, we're doing domain. My smallest x value. In this case, nothing's happening until you hit 3. So my domain is from 3 to infinity. If I tried putting in any number smaller than 3 for x, I'd have a negative under the radical, and then I would be in imaginaries. Okay, if I tried putting like 0 in, I would have 0 minus 3, and I'd be trying to take the square root of negative 3. So obviously that's why that doesn't fall in our domain. Now your range, okay, so you guys, a lot of this, not a lot, it is based off your critical point. So your range, this is my y value, that's my smallest y value. So my range is going to go from negative 2, and then we're getting bigger, so to infinity. Okay, it's everything above that. Remember, you're thinking up to down when you're thinking range. This graph is consistently increasing, so it's increasing starting in an x value of 3, and it will always increase, and it will never decrease because it doesn't come back down. Okay. Let's take a look at number 3. Now we're going to throw an a value in the mix. Okay. Is it shifted left or right? Yes, that's what's inside the radical. You're going to do the opposite, so we're going to go left 4. Okay. Then, is it shifted up or down? Yes, that's a plus 3, so we're going to go up 3. That tells me my critical point, which normally is at 0, 0, is going to go left 4 and up 3. So negative 4, 3 will be my new critical point. Now, is it reflected or stretched? That's where A comes in. Reflected means it's going to go down instead of up, which we've talked about. We just haven't talked about the word reflected. So it's not reflected because A is positive. Is it stretched? Yes, because A is 2. Okay. So now when we graph this, let's do our critical point. We are at negative 4, 3, which is right here. Sorry. That's my critical point. Okay. Now, we need to think about this a value. Normally, the square root of 1 is 1, but I need to double my output, so it's going to go up 2. Normally, I would say, okay, the square root of 4 is my next pretty number that doesn't give me a decimal output. So my square root of 4 is normally 2, but I need to double that and go up 4. The square root of 9, normally I go up 3, but I need to double that and go up 6. And then that's all that fits on the graph. 16 won't fit. So now notice your graph is increasing at a quicker rate, double the rate than it would as the other two graphs. If you just look at them in general, it's a little movement, not little skinnier. It's hard to describe this with skinnier, but it's going up faster. Okay. So our domain here. Use that critical point. The smallest x value you have here is negative 4. So your domain is negative 4 to infinity. The smallest y value you have here is 3. So your range is 3 to infinity. We are still increasing. Okay, we're going up the whole way. So from the x value of negative 4 on, we are increasing and we are never decreasing. Okay. All right, so now let's look at what a decreasing graph looks like. For number 4, we've got a lot going on here. We have shifted left or right. Yes, we are going to the left 8. Okay. All right, sorry. And then we are going up 6. So the number inside tells horizontal, the number outside tells up or down, which tells me my critical point has moved left 8, which is a negative 8, and up 6, which is a positive 6. Is it reflected or stretched? Okay, let's look at this right here. That is a negative a value. So yes, it is reflected, which means you're going down instead of up. And is it stretched? Yes, because we're going to have to triple everything. Okay. Sorry, that's confusing. All right, so if we look, we have the point -8, -6. Just kidding. -8, +6. That couldn't be more confusing today. So we're up here. Okay. Now, we're reflected. So that means we're going down instead of up, and we're going triple the amount. Typically, the square root of 1 is 1. You're going to take that little up 1 and multiply it by -3. So we're going to go down 1, 2, 3. It's just like with quadratics. The square root of 4 is 2. 2 times -3 is -6. So we're going down 6. The square root of 9 is 3. We're going to make that go down because of the negative, and 3 times 3 is 9, so we're going down 9. And here we can keep going. We give some space. The square root of 16 is the next pretty one, which is going to get you out to here. Usually the square root of 16 is 4. 4 times -3 is -12, so we're going to go down 12. And our graph looks like that. So, if you notice, a few things have changed, right? Now we're going down instead of up because we were reflected, which hopefully you're noticing, oh, maybe that means now this is going to decrease instead of increase, right? We haven't had a decreasing one yet, and the only difference here is the negative. It's also going to affect our domain, our range, and all of that. So if you notice, again, up in the top 2 examples in number 1 and 2, you had a nice little curve. Well, this is 3 times that, so all of a sudden that is getting much bigger, okay? So let's talk domain. You guys, go back to your basics. Domain is left to right. So the smallest x value I have here going left to right, this graph starts at -8, okay? So -8 to infinity. Because as soon as I hit -8, I'm going this way. Remember, pay attention to your arrows, you guys. This arrow is going right and down, right? It's always going 2 directions. So if it's going to the right, my domain has to be going towards infinity. Now, this is where people get messed up, because they say my range is 6 to -infinity. This is going down. That means my y's are going to get smaller and smaller and smaller and smaller. You always want to write smallest to biggest. So my range is -infinity, and the biggest y value you're going to get here is 6. This is the top of the graph. That's your max point. You're not getting any higher than that. Okay? So make sure these are going in order, and use those arrows, right? This arrow in number 3 was going to the right and up. So domain to the right and up, right? You wouldn't want these to say -infinity because right and up are both positive infinity. In this case, we have right and down, so we know we need some sort of -infinity somewhere. Okay? Now, this graph, if you read it from critical point on, it is never increasing. All you're doing is going downhill there, so you are decreasing from the x value of -8 to infinity. Okay? All right. Practice these on your homework. Really pay attention to making sure your critical point is in the right spot, and then take your time on the a value, guys. It's so important because tomorrow we're going to add in cubed root and add another a value at you. But if you understand the basics of the a value pattern and connecting it to your parent function, you literally will have to memorize nothing. Okay, so if that's what you're struggling with, please, please, please come see us.